Oh, sweet. I know that one is green. Great. Good evening, everyone. I'm ready. I'm going to be putting on the light. Please turn on the light. The place is going to look a little bit darkish. If it is on, turn it off. Turn that off. Turn off that. Yes. Okay. Thank you very much. And already. All right. So before we begin, what do you think I'm going to do? Apart from nothing. Number one. No, that's not it. Right. For those students who have been longing for substitution before time, well, this is the time now. Good evening, everyone, and welcome to everyone. Welcome to those who are joining for the first time. Welcome to the big timers, those students who have been here from the beginning. Welcome to those who are just taking a look in and out. Welcome to everyone. And of course, thank you for inviting others. Thank you for spreading the word. Thank you for getting in, and thank you for doing what? For commenting, although you have not started that as yet. So, thank you very much for every single thing. And we're going to be solving a pair of simultaneous equations by substitution. And I dare say that, what do I say? When you're solving a pair of simultaneous equations, we take steps to reduce the system of two equations in two unknowns to a single equation in one unknown. On the previous occasions, we did that. Yes, on the previous occasions, we did that by elimination, by the method of elimination, eliminating one of the unknowns. Of course, in this method, one of the unknown is going to be eliminated, but the process that we do that by is substitution. So substitution is what we are at today. And what do? We use transposition to write one equation in terms of the other. Then we substitute. Let me say that again. We use transposition to write one unknown in terms of the other. Then we substitute that into the other equation. That sounds like more than a mouthful, but the process will be quite visible. And of course, I imagine that it is going to be quite simple also. So, this evening is our method of substitution. We don't have to be too crazy about starting too late, about students who are going to miss the initial statements, the introductory remarks. Good night. No. Good night, sir. Are you doing trinomials? The number of trinomials we have done since the start of this course would surely exceed 100. So, we are not going to do that tonight again. And you imagine that if we keep doing things all over again, the examination is not going to return on another day. The examination day is set already. And we have to be sure to be there. For sure. Alright, so let's take a look at there's no doubt that by next week, Monday, all being well, or maybe by the end of the day today, we'll be taking a look at a pair of simultaneous equations of which is one is linear and the other one is not linear. Right. When we take a look at a system of equations of which one is linear and the other is not linear, then it will give rise to a quadratic equation. And then we're going to have, quite likely, a trinomial. In one case, I think we have a difference of 2 squares. But we are going to have, quite likely, a trinomial, which we are going to factorize, because we are going to solve that equation by factorization. But as for today, we are going to be looking at our substitution method. Now, generally, we take from the simpler equation and substitute in the more sophisticated equation. So, let me just put that under the microscope right here. We have x plus y is equal to 3. By transposition, what is y equal to? By transposition, I'm going to give you the opportunity to say something about this one. X plus y is equal to 3. By transposition, what is y equal to? I made this statement as easy as possible. So let's say it again. X plus y is equal to 3. By transposition, what is y equal to? I'm sure that I'm going to see that in a minute. 3 minus x. Of course, we are going to eliminate the x from this side. And that's a positive x. There's no sign preceding it. The default sign is positive. So we will eliminate this x by subtraction. So y is equal to 3 minus x. Now, you are using one equation, which is equation 1. So we're going to say from equation 1, y is equal to 3 minus x. And that is going to be your equation 3. Now students, some books, some teachers do not label that equation. We are labeling that equation 3. And we also have a name for it. We call it the substitution equation. So, from equation 1, y is equal to 3 minus x. We can see it from right here. We eliminate the x by subtraction. So, from equation 1, y is equal to 3 minus x. So, anywhere we see y, we call it 3 minus x. Now, we're going to put that into the other equation. So, we're going to put that into equation 2. So, here's my question. Can we use equation 1 and then put this back into equation 1? Well, we'll answer that question in a minute. But let us say that we put y is equal to 3 minus x. We're going to put that into equation 2. So what do we have? This is your equation 2. We have 3x plus 2y. What is y? Y is 3 minus x. So where we see y, we put 3 minus x. So we have 3x plus 2y. 2 times y is 3 minus x, and that is equal to 7. So now we have one equation in one unknown. And we'll solve this equation as usual. So let's go 3x plus 3 2's, of course that is 6. Then 2 times negative x is negative 2x, and that is equal to 7. What do we do next? Of course, there's no hiccup here because we have one equation and there's only one unknown. Our one unknown is x. So we have 3x minus 2. Maybe we could put that together in another step. 3x minus 2x is equal to 7. Notice that we have the 3x, we have the negative 2x, we have the positive 6 that we have not accounted for. We're going to eliminate this positive 6, and we're going to do that by subtraction. So we minus 6. Notice that we have the 3x, we account for the negative 2x, we have the 7 right here. This 6 is on the left hand side where it is added. We are going to eliminate it by subtraction. So 3x minus 2x, we have that as x, and 7 minus 6, we have that as 1. So we have x is equal to 1. Now students, we surely will be applying quite a bit of foresight by calling this equation, which we know to be the substitution equation. We call that equation equation 3. Because when we get the value of one of the unknowns, we may substitute it into any of those equations that we have there. So we may substitute that into this one, or this one. Of course, this one is the rearrangement of that one, but we may substitute into any of those 3 equations in order to find the value of y. Now, we label this equation, might not be done in some books, might not be done by some teachers. We label that equation 3 because when you find the value of one of the unknowns, it is the easiest equation to give you the value of the other. And you can do it on the spot. So let's just do it on the spot. If x is equal to 1, look at this now, x is equal to 1. Put 1 right here. Instead of x, we put 1 here. What is the value of y? Y is equal to, and the x is 1. Y is equal to, what will x be, y be equal to on this occasion? Let me see if anybody figured that out as yet. Equations 1 and 2 are the original pair of simultaneous equations given to us. So the 7 did not come by some pure spurious mean. It was given to us as a part of the problem. Okay? Yeah, so the problem has two equations. The problem has these two equations as a pair of simultaneous equations. Two equations with two unknowns. Right. Do I have anybody answering the question that I just asked? The value of x is equal to 1. If you put the value of x which is equal to 1 right here where we see x, we put 1. What would be the value of y? Come on, students. We have 36 students. Everyone should know the answer by now. Exactly. So even without doing any other thing, we already have the answer. Right? We have the answer already. But we are going to, x is equal to 1. We are going to put that into equation 3. Into equation 3. When we put that into equation 3, what do we get? Y is equal to 3 minus 1. So y is equal to 2. So finish up by saying x is equal to 1. Y is equal to 2. And now your favorite is coming up. I'm sure that you're going to have a lot of fun right here. Let's go. 4x minus 3y is equal to 1. And x plus 3y is equal to 19. And that's your equation 2. So right there we have a pair of equations. We want to use one equation to write one unknown in terms of the other. For example, x is equal to something or y is equal to something. In this case, we use y because we are opting to use the simpler equation. But we should attempt to be so flexible that we do not have to use the simplest equation or the simpler equation. And we'll take a look at how we could be that flexible. But first of all, what should we say for this one? Alright, I'll make the decision. Later on, when you're on a speed, then you will make all of the decisions. Let's go. X is equal to, from, I'm going to put the from out somewhere. From equation, I'm going to use equation 2 because I have a single x there. From equation 2, x is equal to, so if we are at equation 2, by transposition, what would we say x is equal to? Let me see if anybody can figure that out. By transposition, what will x be equal to in this case if we use equation 2? X is equal to Let's go. From equation 2, this one, x is equal to, if we are transposing by transposition, x would be equal to, x would be equal to 3y minus 19. No. Take a second, go at it. X will be equal to the person was 19 take 3y. Right, 19 take away 3y. So 19 minus 3y, and that is our equation 3. That is our equation 3. And we are going to put that, because we take it from equation 2, we are going to put that into equation 1. Question, students. Notice here, we took from equation 1 and we put it into equation 2. Here, we are taking from equation 2 and put that into equation 1. So here's my question to you. If we take from equation 1 and put it back into equation 1, what will be the result? What would that say? If we take from equation 1 and put it back into equation 1, what will be the result? One. Let me see. No, I'm not repeating it. All right. If we do that, we're going to get 0 is equal to 0. Right? If we do that, we'll get 0 is equal to 0. Which of course is correct, but that will not assist us in solving the equation. Let's go. So we are taking from equation 2 and we are going to put that into equation 1. So we see that what? X is equal to 19 minus 3y. I'm going to put the into out somewhere. Into equation 1. So we have x is equal to 19 minus 3y. So let us go for it. We're going to put that into equation 1. X, 19 minus 3. So we have 4x minus 3y is equal to 1. So let's go. 4. We're going to multiply that by x. What is x? X is 19 minus 3y. 4x. 4 times x is 19 minus 3y. So after we have 4x, we have 4x minus 3y. Then we subtract 3y. And the result is 1. That's what we have. So 4 times x. 4 times x is 19 minus 3y. Then we have minus 3y goes there equals 1. Of course, now we have one equation, and the only unknown in the equation is y, although we have more than one occurrences of y. So let's go. 4 times 19. I'm going to teach you a bit of mathematics, students. If somebody asks you 4 times 19 and it does not ring, just say 4 times 20. That is 80. Because you can do that quite easily. 4 times 20 is 80. And then you subtract 4 for each one. And then you'll get the answer. So 4 times 19 is actually 76. 76 minus 4 times negative 3. 4 times negative 3y, negative 12y. Of course, there's a negative 3y there, and that's equal to 1. That's nice. So, although we don't have to take an extra step are going to eliminate the 76 from this side. Let me ask a question. What operation are we going to use to eliminate this 76? Let us eliminate 76 from this side. What operation do we use to eliminate the 76? Let's go. Well, we put it like terms already. And we're just going to write that as one term. What operation, what arithmetic, let me say it then. What arithmetic operation are we going to use to eliminate the 76? What arithmetic operation will we use to eliminate the 76? That is why I asked. Why do you say add 76? So we're going to say 1 plus 76. Is that correct? That is why I asked. Because I am almost sure that some student would make that mistake. No one with another answer? But sir, the 76 is positive. I didn't say it was right. Since you know, then why don't you say the right thing? Okay, balance the equation by doing what? It will be subtraction since it is positive. This 76 is positive, so it will be what? Minus 76. This negative sign is not pertaining to the 76. It does not belong to 76. It belongs to 12y. So the 76, not preceded by any sign, we know that the default sign is subtraction. Sorry, let's say that again. The default sign is addition or a positive sign. So the 76 is positive. So we will eliminate that by subtraction. And we put these together, we get negative 15y, and 1 minus 76 is negative 75. Negative divided by negative is positive. So y is equal to 5. Y is equal to 5 into, of course, how do we arrive at y is equal to 5? We are going to divide both sides by negative 15. So this y is accompanied by negative 15 related by multiplication. So we will eliminate the negative 15 by division since it's being multiplied by y. And we will divide by negative 15 on the right hand side also. So y is equal to 5, and we are going to put that into equation 3. Alright. Look at this now. Let us examine the equation 3. This is our equation 3. Y is 5. So what is x? X is equal to 19 minus 3y, and y is 5. X is equal to 19 minus 3y. Y being 5, what is the value of x? I'm looking for it now. I see 4. Yes, student, because all that we do is put a 5 here. 3 5s 15. 19 minus 15 is 4. So that is how simple it is when we find one unknown to find the other unknown if we substitute it into the put it into the substitution equation. Also, okay, so let's go. We put that into equation 3. We get x is equal to 19 minus 3 times 5. So x, I don't want to put 19 minus 15. And then x is equal to 4. So what is the final analysis? X is equal to 4, y is equal to 5. That's the final analysis. So, notice that the next problem that we have right there is the same problem that we had before. Right? So that this one is the same as this one. Right? Yes. And we are going to have some fun. Now, notice that we say from equation 2, x is equal to, now we're going to say from what? From equation 1. And what are we going to make the subject of the formula? 3y. What is 3y equal to? I'm seeing if that is going to run into the bright spot. Not necessarily. I'm going to put it over some more though. From equation 1, 3y is equal to what? What is 3y equal to? Now, students, we are making 3y the subject of the formula. As I promised that this evening you might see something in substitution that you have not seen before. Yes, I promise you that you might see something that you have never seen before. So we are making 3y the subject of the formula, and we are doing that from equation 1. So from equation 1, 3y is our subject. So what do we say? From equation 1, by transposition, what is 3y equal to? No one with an answer yet? We are making 3y the subject of the formula. No one with an answer as yet? All right. All right, let me write it down then. From equation 1, 3y is equal to 4x minus 1, and that is equation 3. Hopefully, it's not in the bright light. Well, it's not too bad. When we did transposition. When we did transposition, students were encouraged to to convert the term to positive in the event that the proposed subject is in a negative term. So when the proposed subject is in a negative term, then you are instructed to cause it to be in a positive term. Because when you cause it to be in a positive term, then the transposition or whatever manipulation that you have following would be simpler. It's not like if it is in a negative term, it is impossible. If it is in a negative term and you are diligent It's just as simple. But when it is in a negative term, you should try to convert the negative term to a positive term, and we did this right here. So what did we do? We did a double switch. So we switch it over in our minds and then write it again. So let me give you an idea what we did. We have, I hope that is not in it, 4x minus 3y is equal to 1. Remember now that when we intend to get this 3y, which is the proposed subject, to be in a positive term, we would add it to both sides. So we have the 3y over here as a positive 3y. The 4x remain the same. There's nothing affecting the 4x. But the 3y, which is our intended subject, our intended, yes, our proposed subject. The 3y, which is our proposed subject, by adding it to the right-hand side, it is going to be accompanied by this one. We are not writing it there, but it is going to be accompanied by that one. So we do what? We eliminate the one at the same time by subtracting one. So we eliminate the 3y from this side by addition, and we eliminate the 1 from the right-hand side by subtraction. That is what we have. Then what? Then this switch is easy, because 4x minus y is equal to 3y. So 3y is equal to 4x minus 1. And not 1 minus 4x. Because if it is 1 minus 4x, it would be negative 3y. And let us put that into equation 2. I am sure that there's at least one individual here who would have seen a pair of simultaneous equations being solved by substitution and maybe never see somebody substituting 3y for 3y. Now, what do we have here? We have an occurrence of 3y right here. And we have an occurrence of 3y right here. So if we can substitute 3y for 3y, then it's just as substituting y for y or substituting x for x, because 3y is identical to 3y. So that substitution can be made. So let us make that substitution. And I'm going to show you some other substitution that we can make later on, if possible. We're going to put that into equation 2, and you're going to see that it follows through quite easily. So let's put that into equation 2. This is our equation 2. So let's go. We say what? X plus 3y. X plus 3y. What is 3y? 3y is 4x minus 1. So when we have x plus 3y, we know that 3y is 4x minus 1. So we have what? Instead of the 3y here, we put 4x minus 1, and then that is equal to 19. Students, we have to learn to be flexible. So just as how we substitute y for y, or x for x, we can substitute 3y for 3y. We can substitute 10x for 10x. And we're going to see something like that on another occasion this evening. So there we have the one equation in one unknown, which is simpler than the one that we have here. And we write what? X plus 4x, that's 5x, is equal to 19. We are going to eliminate this one by addition. So 20. So x is equal to 4, and we substitute that into equation 3. Put that into the substitution equation. Of course, we can just put the 4 here. So we will have 4 times 4, that is 16, minus 1, that is 15. So we'll have 3y is equal to 15, so y is equal to 5. So we can do it on the spot. Just put the x is equal to 4 right here. 4 times 4 is 16, minus 1, that is 15. So 15 is here, and we have 3y there. 3y is equal to 15, y is equal to 5. But let us spell it out. 3y is equal to 4 times 4 minus 1. So 3y is equal to 16 minus 1. So 3y is equal to 15 with y equals 5. So x is equal to 4, y is equal to 5. So we see that we are not limited by anything as long as we take mathematically legitimate steps. Yes, let our steps be mathematically legitimate, and we are not limited by anything. We are just going to be just finishing up. All right, so these are our introductory problems. I doubt that our classwork problems are going to be as many as the last occasion. We are doing the odd numbers. Sometimes I'm going to do more than one takes. Let's go. So we're going to do numbers 1, 3, 5, 7, 9, and we are not going to do number 11. So we are free from one of those problems. But we're going to go until 8 o'clock, and I'm going to be taking more than one go at some of the problems that we are going to solve. Let's go. Quite likely, early up, early up. All right. So our favorite. That's your equation 1. Anything else? 2x minus 2y is equal to 6. 2x minus 2y is equal to 6, and that is your equation 2. Nice. What do we do apart from nothing? Right, so I would surely like to see I would surely like to know what you would make of it from equation what is equal to what. And I'm going to show you some new styles of substitution. Some new styles of substitution. Let's go. All right. So I'm going to go straight forward with from equation 1. Oh, this one is right in pale already. All right, that's not bad. So from equation 1, what? x is equal to 7 minus 3y, and that is your equation 3, because that's your substitution equation. Is that okay? Yes, it is. So from equation 1, x is equal to 7. We will eliminate this positive 3y by subtraction, and that will be your equation 3, your substitution equation. And if we take from 1, we are going to put into 2, into equation 2. That's what we're going to do, put that into equation 2. And where we see x, we put 7 minus 3y. So 2 times, where we see x, we put 7 minus 3y. Then we minus 2y, and then that is equal to 6. So x is 7 minus 3y. We established that from that equation. Then 2 times x, so 2 times 7 minus 3y minus 2y is equal to 6. We have one equation in one unknown, and let us go straight ahead. So what do we say? We have 2 7, so we have 14 minus 2 3s, so we have 6y minus 2y is equal to 6. And some of the students would say, all right, get them together, no problem. So we have negative 6y minus 2y is equal to 6 minus 14. So I'm waiting for this one now. What is 6 minus 14? 6 minus 14. What do we say about that one? 6 minus 14? For all of the negative 8, negative 8. Some saying it's 8. You have to put the sign. Right, so this one is negative 8. What about negative 6 minus 2? Negative 6 minus 2, what is that? Negative 6 minus 2. That 4 is not right. Negative 8. Whenever we add numbers that have the same sign, we add the values, and the answer will take the same sign as the numbers that we have added. So negative 8y. I hope that you can see that if we have negative 8y is equal to negative 8, then y is equal to negative 8 divided by negative 8, which is positive 1, and we're going to put that into equation 3. Put that into the substitution equation. If we put that into the substitution equation, y is equal to 1. Put y is equal to 1 right here. What is x equal to? Put y is equal to 1 right here. What is x equal to? Students, be on your keys. Right, so for sure, it's 4. So x is equal to 7 minus 3 times 1. So x is equal to 7 minus 3. X is equal to 4. And we might spell it out now. X is equal to 4, while y is equal to 1. Maybe I'm going to take a second take on this one. X plus 3y is equal to 7, and that is equation 1. And 2x minus 2y is equal to 6, and that is equation 2. I'm taking a look at it several times. What's my intention for taking a look at it several times? Because I want to do a substitution. that is not, that we have not done yet. But let it go for now. Do we? All right, maybe I reserve that for another one. So let's go merrily to number 3. I like number 3. So let's go to number 3. Two x minus y is equal to 1. And that is your equation 1. Wow. And negative 2x plus 3y is equal to 5. I hope that is what is there. I didn't look. Negative 2x plus 3y is equal to 5. Great. So yes, what do we say? Because the students want to single out the y. You want to single out the y because you can just have y. Because y is not accompanied by any number. Although we know that the coefficient is 1. And if we want to be exact, because it's a negative y there, the coefficient is negative 1. I'm going to say from equation 1. Students, give me the result for this one. From equation 1, y is equal to, right, so tell me what y is equal to. From equation 1, y is equal to, I'm going to put it back. But this y is equal to, from equation 1, y is equal to what? Two x minus 1. Yeah! Yes, so that's correct. Y is equal to 2x minus 1. We eliminate this negative y, so we're going to have a positive y here. We're going to eliminate this 1, positive 1, we're going to have a minus 1. So we're going to have 2x minus 1 is equal to y. So y is equal to 2x, x minus 1. And that is your equation 3. And that you're going to put into equation 2. Alright, I'm not going to throw away these markers yet. I'm going to throw away these two markers together. So let's go. When we put that into equation 2, what do we get? We get negative 2x plus 3 times y. What is y? See? Put that into equation 2. Negative 2x plus 3 times y. What is y? 2x minus 1. And that is equal to 5. So negative 2x, put it that way, negative 2x plus 3 times y, which is 2x minus 1, is equal to 5. We have what? One equation with one unknown. And close it, and then equal 5. So what do we say now, apart from nothing? Negative 2x plus 3 2's 6x minus 3 is equal to 5. I can see what this is turning out to be already. So what do we say? Negative 2x plus 6x is equal to 5 plus 3. So negative 2x plus 6x Can somebody give me the answer for that? Negative 2x plus 6x. I will do the right hand side. 4x. Students, at all steps of the game, you have to know your directed numbers, else you're going to make a meal of the problem. So x is equal to 8 divided by 2, 8 divided by 4, which is equal to 2. And we're going to put that into the substitution equation. Put that into equation 3. Put that into x is equal to 2. So if we just put a 2 here, y is equal to 2, x is equal to 2. Sorry, y is equal to 2. And then, of course, x is equal to 2. What will be the value of y? Can anybody tell me what the value of y is? If the value of x is equal to 2 right there? The value of x is equal to 2 right there. What will the value of y be? 3, exactly. So we have y is equal to 2 times 2 minus 1. One step. Y is equal to 2 2's 4 minus 1, 3. So x is equal to 2, y is equal to 3. For some students who missed out on the substitution, when, of course, we did not use something with a coefficient of 1. Let's go again. 2. I'm looking at the glare and where I'm writing. Maybe it's wide enough. 2x minus y is equal to 1, that is equation 1. And then what? G. Negative 2x plus 3y is equal to 5, and that is equation 2. And as I promised, I'm going to throw away both markers together. So the two markers will be going away together. Oh yes. All right. So let's see what you can say about this one, students. From equation 2, 2x equals. So from equation 2, 2x equals. I'm looking if it's going into this. I'm going to write it over because it's going to go inside here. 2x. From equation 2, 2x is equal to what? From equation 2, 2x is equal to nothing yet. I'm going to give you just a few more seconds. From equation 2, 2x is equal to 3y minus 5. No, you put plus 5. You made a meal of it. And that is your equation 3. Okay. Beautiful. So from equation 2, 2x is equal to 3y minus 5. That's equation 2. Sorry, equation 3. And we're going to put that. This marker is not finding a flat point as yet. We're going to put that into, that's better. We're going to put that into equation 1. When we put that into equation 1, what do we have? Where we see 2x, yes, when we see 2x, we put 3y minus 5. So the 2x is replaced entirely by 3y minus 5. 3y minus 5. That's 2x. We're going to replace 2x with 3y minus 5. Minus y again, and that is equal to 1. So we have one equation with one unknown. Of course, that's a minus y right there. A minus y. Right, so we say what? 3y minus y is equal to 1 plus 5. So that is going to be 2y is equal to 6. So y is equal to 3. And we're going to put that into equation 3 as usual. Put that into the substitution equation. So that goes into the substitution equation, which is right here. Somebody please tell me what x will be equal to. Put that y is equal to 3 right here. Anybody else yet? Exacto. But let us do it. So we'll have what? 2x is equal to 3, y is 3, so it's 3 times 3 minus 5. So 2x is equal to 4, so x is equal to 2. We finish up by declaring that x is equal to 2, y is equal to 3. So we have 2 takes on number 3. I'm sure that one of them, I am not going to do 2 takes on that one. Which one is it that I'm not going to do 2 takes on? Alright. Which one is it that I'm not going to do takes on? But we have number 3 already. So let us move on to number 5. I'm going to do 2 takes on number 5 because I'm sure that I will not do 2 takes on number 7. So let's go for number 5. X plus 3 is equal to 12 and 2x minus 3y is equal to 6. Let's continue. Number 5. What do we say? X plus 3 is equal to 12. X X plus 3y is equal to 12. That is equation 1. And 2x minus 3y is equal to 6. 2x minus 3y is equal to 6. That is equation 2. So from which one? From equation 1. from equation 1, x is equal to, that one is easy. From equation 1, by substitution, what is x equal to? From equation 1, x is equal to, I'm soliciting the answer from you. So let's see what you make of that one. Yes, I'm soliciting the answer from you. That's a nice one. Alright, so let's go. So x is equal to, if we are making x the subject of the formula, the 12 remains there, and the 3y that is added to x here is eliminated by subtraction. Subtraction, and we do the same on the other side, minus 3y. And that is your equation 3. And we'll put that into equation 2. Put that into equation 2. See, just going up there, 12 minus 3y. When we put that into equation 2, what do we get? Where we see x, we put 12 minus 3y. So 2 times x. X is 12 minus 3y. So 2 times x minus 3y. 2 times x minus 3y, and that's equal to 6. That's a lot of subtraction. I guess it is going to work out just fine. So what do we say? 2 times 12. So 2 times 12 is 24 minus 2 times negative 3y. Of course, not minus 2 times negative 3y. Minus 2 times 3y, 6y, minus 3y is equal to 6. So what do we have? A negative 6y minus 3y is equal to 6. How do we eliminate that 24? How do we eliminate that 24? How? Subtract 24 right away. Minus 24. So my question again, you know you're going to ask that question. What is negative 6 minus 3? What is negative 6 minus 3? What is negative 6 minus 3? Negative 9? That's fine. Negative 9y. And what is 6 minus 24? Yes, the negative 9 is fine. 6 minus 24. Negative 18. So y is equal to negative 18 divided by negative 9. Negative divided by negative is positive, and 18 divided by 9 is 2. And we put that into equation 3. Put that into equation 3. So, right here, if y is equal to 2, what is x equal to? Put the 2 right here. 12 minus 3 times. So what is the x going to be equal to? Three. Let's see how you get that 3. Y is equal to 2. So we're going to put a 2 here. So we're going to have minus 3 times 2, so that's negative 6. 12 minus 6. So let us do it. So x is equal to 12 minus 2 times 2. Is that? No, it's 3 right there. 3 times 2. So x is equal to 12 minus 6, which is equal to 6. So we may declare that x is equal to 6, y is equal to 2. Oh, let's go. Same problem 5. There you go. From equation 2, 3y is equal to. What is 3y equal to if we are using equation 2 on this equation? Let's go. From equation 2, 3y, what is 3y equal to? I'm looking down at it. I'm waiting for the answer. From equation 2, what is 3y equal to by transposition? I'm giving the last few seconds. If I see another move to the screen, I expect to see that. Okay, so we are making 3y the subject of the formula. We will eliminate the 3y from this side by addition. And of course, in the same breath, we'll eliminate the 6 from this side by subtraction. So we're going to have 2x minus 6 is equal to 3y. So 3y is equal to 2x minus 6. And that is your equation 3. And you're going to put that into equation 1. So in equation 1, wherever you see 3y, you're going to replace that with 2x minus 6. So let's go. Into equation 1. That's your equation 1. We have x first plus 3y. What is 3y? 3y is 2x minus 6. And that is equal to 12. That's nice. So we can see immediately that we have x plus 2x, which is 3x. X plus 2x, that is 3x. We're going to eliminate this 6, that negative 6. So it's going to be 12 plus 6, which is 18. And of course, finish up by saying x is equal to 18 divided by 3, which is 6. And we're going to put that into. Do I put it into anything? Yes, put that into equation 3. We're going to put that, I'm going to put it a little bit, like a half an inch over. equal to 6 into equation 3. So we have x is equal to 6 right here. So what do we have? I'm not going to work it out in the mind because the students are taking too long. 2y is equal to 2. The value of x is 6 minus 6. So 3y is equal to 2 6 is 12 minus 6 is 6. So y is equal to 6 divided by 3, which is 2. So we may declare x is equal to 6, y is equal to 2. So we have done 2 takes on number 5. We're going to do number 7. I'm going to do 1 take on number 7, so we are through. 2x plus 3y is equal to 1. 2x plus 3y is equal to 1. And 5x plus 3y is equal to 16. I'm going to do 2 takes on number 7. Yes, I'm going to do 2 takes on number 7. From equation 1, 3y is equal to, no, I'm not going to do 2 takes, I'm going to do 1 take. From equation 1, 3y is equal to, let me see if there's anybody prepared. Students, you have to lively up yourself because the one that is going to come after this is going to be more challenging. It's a love song that we used to play. All right. So let's go. 1 take. From equation 1, 3y is equal to 2x minus 1. 1 minus 2x. Notice that I'm not labeling it. Should I? Yes. Equation 3. From equation 2, 3y is equal to, so go to equation 2 now. That's a different style of substitution that we are doing now. From equation 2, 3y is equal to what? That's surely another style of substitution we have. Okay, that's nice. Let's see what we have. Nothing. All right, let me put that in. 16 minus 5x. That is equation 4. Let's see if it is out of the glare. Well, that will work. Notice that we use two froms. I'm demonstrating to you another type of substitution. So what do we have? We have 3y is equal to 1 minus 2x. We have 3y is equal to 16 minus 5x. So what do we say then? I think that's an easy conclusion to arrive at. Because if this is equal to 3y and this is equal to 3y, it means that these two are equal. Let's see if you can make that deduction. If this is equal to 3y and this is equal to 3y, it means that both of them are equal. So what do we say? 1 minus 2x is equal to 16 minus 5x. So we have one equation in one unknown. We equate the two 3y's and then we move forward. So what do we say? We have a positive 5 here, 5x minus 2y, and then we have a positive 16 there, minus 1. I think that I made a mistake with this one. So let's go. Put an x there. Right. Right. So by doing that, when we eliminate the 5x from this, we will have a positive 5x there. When we eliminate the 1 from here, we will have a negative 1. And what do we have? 3x is equal to 15. X is equal to 5 into, you may put that into any one of these two equations. Maybe you want to put it in the baby one, so put that in 3. It's a little bit simpler. So if we put that into equation 3, what do we have? 3y is equal to 1 minus 2 times 5. Go back on your directed numbers. This is 2 5s 10. So 1 minus 10 is negative 9. 1 minus 10, that's negative 9. So y is equal to negative 3. So we declare that x is equal to 5. Y is equal to negative 3. So this is another kind of substitution that you may make use of. We see occurrences of 2y in both equations. We make them the subject of the two equations or the two formulae, and then equate their right-hand sides. That's another nice one. Alright, so now we will do two takes on what? We'll do two takes on number 9 and see what we make of it. Two takes on number 9. Two takes on number 9. So let's go. Number 9. Students, sometimes a problem is given with negative signs inside here. As soon as you see the negative signs, you are skeptical about it. But I'm going to show you that anytime you see in a problem something that looks upward, that you should what? Take it to your advantage. But let's go in the way that we imagine that they would want us to go. Number 9. Number 9. X minus y is equal to -2. That is the equation 1. And 2x plus 3y is equal to 21. 2x plus 3y is equal to, I hope it's 21. Let me look at it again, because I'm not making any mistake. X minus y is equal to -2. 2x plus 3y is equal to 21. Right. I hope that I have your attention. Let's just go straight ahead and say what? From equation 1, x is equal to, we're going to eliminate this negative y. The negative y is going to be positive. We're still going to have the -2. And that's it. So x, we are saying from equation 1, we are making x the subject. We're going to eliminate this negative y by addition, so we'll have a positive y there. The -2 will remain, and that's it. And then that is equation 3. So we're going to put that into equation 2. So let us go straight ahead and put that into equation 2. What do we say? Take from equation 1, put that into equation 2. Where we see x, we put y minus 2. That's going to be into equation 2. Where we see x, we put y minus 2. So 2, then x. X is y minus 2. So 2x then plus 3y is equal to 21. And we say what? 2y minus 4 plus 3y is equal to 21. Of course, we can see that 2y plus 3y, that is your 5y. We will eliminate this -4 by addition, so it's going to be added to the 21, 25. Y is equal to 5, and that goes into equation 3. You're supposed to love this one. Because y is equal to 5, just put a 5 here. If you put a 5 here, just 5 minus 2, that's 3. X is equal to 3. So x is equal to 5 minus 2, so x is equal to 3. So we may finish up by declaring that x is equal to 3, y is equal to 5. No. Alright, so we're going to do another take on question 9. Let's go. Now, as I said before, the same number 9. X minus y is equal to negative 2. That is your equation 1. And 2x plus 3y is equal to 21. And that's your equation 2. As I said before, because of the negative sign, some might deem the problem to be a little bit awkward. But when you see stuff like those, you should look for something that makes it simple. Or if you proceed in a common sense way, then you'll see that the entire thing is easier than you imagine. All right, let's go. So let's say, from equation 1 again. Now, if you look into equation 1, if you eliminate this y from the left hand side, and then eliminate this negative 2 from the right hand side, then everything will be positive. So you will have from equation 1, you will have equals to negative 2 is going to be eliminated, so you're going to have x plus 2. The y is going to be eliminated, so you're going to have a positive y. So y is equal to x plus 2. That is equation 3. Students, I am almost sure that for the rest of the problem, you will never see another negative sign. Just by making the correct decision early. So you make that correct decision early, you will never see a what? Never see another negative sign in the entire problem. Never see another negative sign. That's what I am sure of. You will never see another negative sign. Alright, so let's continue. So now we're going to put that into equation 2. And let us finish up by saying what? Put that into equation 2. Where we see y, we put x plus 2. So we have 2x plus 3 times y, so that's 2x, plus 3 times y, and y is x plus 2, and that is equal to 21. And we'll finish up by saying 2x plus 3x plus 6 is equal to 21. And 2x plus 3x, that's 5x. And 21 minus 6 is 15. So x is equal to 3 into equation 3. When you put that into equation 3, what do we get? X is equal to 3. So y is equal to 3 plus 2. y is equal to 3 plus 2, so y is equal to 5. So x is equal to 3, y is equal to 5. Okay, so that's the classwork for what we intended for today. Now, it so happens that we have half an hour left, so we are going to continue. Needless to say, this is the book that you're going to use Monday in the instructional class. Right, so that is for the YouTube, this is for the TikTok. So the algebra book is going to be finished by Monday. We're going to finish like maybe a few minutes in the class. But we have 4 problems to do for the next subtopic. Yes, so we have 4 problems to do for the next subtopic. It's substitution again, students, for the most part. For the most part, it will be substitution. However, on this occasion, one of the equations, yes, right. One of the equations will give rise, because one of them is non-linear. So one of the equations is linear and the other one is not linear. Right. So one of the equations is linear, the other one is non-linear, and we are going to solve the pair of simultaneous equations. I think that I have them solved in the instructional manual, but let's do them. Let's see who is sharp and ready. I am ready. Sorry about that. Yeah. So, 1. X plus y is equal to 7. Xy is equal to 12. That is equation 1. And that is equation 2. And when one of the equations is linear and the other one is non-linear, the approach that we should take is, the general approach is substitution. Yes? The general approach is substitution. But, as you will see, if not today, then Monday, that it is not limited to substitution. So let us substitute. So we are going to say from equation 1, y is equal to 7 minus x, and that is equation 3. 7 minus x. So from equation 1, y is equal to 7 minus x. And if we take from equation 1, we're going to put that into equation 2. All right. So when we put that into equation 2, what do we have? We have x. Then we have y. Y is 7 minus x. But on this occasion, it is being multiplied by 7 minus x. And that is equal to 12. So now we have what? One equation in one unknown. So what do we say? X times 7 is 7x. X times negative x is negative x squared. and that is equal to 12. Now, students, you start to see your quadratic equation because you see what? The x squared right there. Now, I'm going to demonstrate that we are not limited to one side of the equation, right? Right, so we realize now that we can just put 0 here. Let the left hand side be 0. And then put the entire trinomial on the other side. So we'll eliminate this negative x squared by addition. So we have a positive x squared here. We'll eliminate the negative 7x by, the positive 7x. We'll eliminate the positive 7x by subtraction. So negative 7x right there. The 12 remains the same place. It stays on that right hand side with that same side. So 0 is equal to, what are the factors? We have, of course, x squared minus 7x plus 12. What are the factors? The product is 12. The sum is negative 7. What are the two numbers? The product is 12. The sum is negative 7. What are the two answers? Somebody says 4, 3. Anybody with a better answer than just 4, 3? X minus 4, x minus 3. So the values of x will be what? X is equal to 4 or 3, and we're going to put that into equation 3. Now, notice that we have two values for x. Therefore, we should have corresponding values for y. So what do we say? Y is equal to 7 minus x is what in this occasion? 4. So y is equal to 3. Then we say what? Y is equal to 7 minus, what's the other value of y? 3. So y is equal to 4. So what do we say? Now, remember now that we have what? Two values of x because of the quadratic equation, and we have two corresponding values of y. So we say that when x is equal to 4, y is equal to 3. And when x is equal to 3, y is equal to 4. Nice. That one is short, students. That one is short in comparison. The next one is not just going to be, it's going to be wide. Let's go. It's not going to be just long, it's going to be wide. So x squared, look at this now. This is where we start. Number 2. Students, you have to study x squared plus y squared. X squared plus y minus 3x plus 2y is equal to 12. Minus 3x plus 2y is equal to 12. That is your equation 1, students. And then what do we say for equation 2? Apart from nothing. X plus y is equal to 6. X plus y is equal to 6, and that is equation 2. Maybe you should put it closer so that the equations can be seen. say? X plus y is equal to 6. X plus y is equal to 6. That is equation 2. So we're going to say, well, of course, we're going to use the simpler equation. From equation 2, and of course, we may write what? Y is equal to 6 minus x. I'm writing it too wide. From equation 2, y is equal to 6 minus x, and that is equation 3. So y is equal to 6, we subtract the x. Then what do? We put it into equation 1. We put it into equation 1. Notice what I've done here, students, is that usually I put into down here, into equation, whatever next equation is. But notice that I put it here. I put it there because I imagine that what? The problem is going to be extremely wide on the board. That's why I put it there. Nice. So what do we say after that apart from nothing? So we begin. X squared. We're going to put that into equation 1. Y is equal to 6 minus x. We're going to put that into equation 1. First thing we have is x squared. So let us put that down. X squared. Plus y squared. What is y? 6 minus x. So 6 minus x all squared. Minus 3x. So we put it everything. X squared plus y squared minus 3x plus 2y. What is y? Y is 6 minus x. 6 minus x. And then what do? Equal 12. Minus 12 is equal to 0. So instead of saying that it's equal to 12, we already take steps to ensure that the right hand side is 0. Nice. So let's go. X squared plus 36 minus 12x plus x squared minus 3x minus 3x plus 12 minus 2x minus 12 equals 0. That's very wide. Now, students, let us go right here to what we did. X squared goes there. 6 minus x all squared. What do? Students who were here at the beginning and we did the perfect square. Students, we did the perfect square. Do not forget the perfect square. The perfect square, we square the first and it goes there. We square the second and it goes all the way there. Then there's a middle term that is equal to 2 times the first times the second. So everybody who would have forgotten that, you would have gotten this problem wrong. Because when you have a perfect square, you do not just put 6 squares 36 and when we square the x we get x squared. No, it's not like that. There is a middle term that is equal to 2 times the first and the second. I'm not just mentioning it. When we did factorization, we outlined the entire thing and we worked out 2 separate exercises that are based on the fact that for a perfect square, we have the square of one term, the square of the other, and then the one in the middle is 2 times the first times the second. For sure. So what do we say now? We're going to put all the x's together and whatever else to put together, we're going to put those together. So let's go. We have x squared with x squared, so we're going to have 2x squared. It's not going to be so well again, students. What about the x's? We have a negative 12x, we have a negative 3x, and we have a negative 2x. That sounds like a negative 17x. I hope that it works. So we have a negative 12x, a negative 3x, and negative 2x. Putting all of those together, we'll get a negative 17x. Then the pure number, of course, this is going to eliminate this right there. The positive 12 and the negative 12 will go away. We have what next? 36. Plus 36 equals 0. That's nice. So you see how far we have gotten, and we are not close to the end of it yet, because we need to be able to factorize that trinomial. Let's go. Do not forget that when the coefficient of x squared is not equal to 1, we don't write it down. We do not write that down just simply like that. Although we can do it, but we don't do it. Now what do? We say 2 times 36 is 72. Now students, the product is 72 and the sum is negative 17. What are the two numbers? So let's go. The product is 2 times 36, which is 72. The product is 72 and the sum is negative 17. What are the two numbers? The sum is negative 17 and the product is 72. No answer. All right, let me put those in. Negative 8x minus 9x. What's common? 2x, x minus 4, minus 9, x. Negative into positive is negative. So, x minus 4. Students, everything that we are doing here was covered. The substitution method was covered. The solution of the quadratic equation was covered. The factorization of the trinomial was covered. The solution of the linear factor was done. So in this case, x is equal to students, we are just working this thing for it's not 2 hours yet. Write on it too, as a matter of fact. Maybe we just finish at that problem. Well, yes, I'm going to finish when this problem is finished. It's not 2 hours. Students, when I go to the examination is 2 hours and 40 minutes. So, if you can hold out for 2 hours, remember that your full exam is 2 hours and 40 minutes. And when I'm going to be giving practice examination, the examination is going to be that long. No, it's going to be 2 hours and 20 minutes. And the students who would have ignored the mathematics resources, when it comes to the examination time, you're going to pay. You're going to pay for that. Don't expect me to have mathematics resources to sell you, because it doesn't matter. Let's go. So x is equal to what on this occasion? 4 or 9 over 2. And we're going to put that into equation 3. I'm going to put it not so well. So x is equal to 4 and 9 over 2 into equation 3. So let's go. Put that into equation 3. For those students who did fractions, you're going to be onto it. Those who did not do fractions, you might find it a little more challenging. So let's go. X is equal to, I mean that when we did fractions. When we did fractions, if you were in it. So let's go. Put that into equation 3. So y is equal to 6 minus 4. So y is equal to 6 minus 4. So y is equal to 2. Next one. Y is equal to 6 minus 9 over 2. I hope that you recognize that 6 is 12 over 2. So 6 is 12 over 2. Of course, if you divide 12 by 2, you're going to get 6. So there's no difficulty. So we're just writing it. It's the same 6, but we are writing it with a denominator so that we can manipulate it easier. So y is equal to 3 over 2. So we're going to finish up by saying what? When x is equal to 4, y is equal to 2. When x is equal to 9 over 2, y is equal to 3 over 2. Yeah, it's a long problem, but there's nothing new inside here. Nothing new under the sun. Inside of that problem, you have your substitution that you know. Inside there, you have your perfect square that you know. You have your addition of algebraic expression that you know. You have your factorization of trinomials that you know. We have 2 linear fractions, you can solve a linear equation. So, although it is cumbersome, for every component that we have in this problem, we would have covered that in class already. Alright, so you have to get accustomed to sitting and remaining focused for 2 hours. So what do I say? Alright? So we'll continue on Sunday. And of course, Sunday is a problem-solving class. And quite likely, we're going to just solve quadratic equations, the even numbers, and we're going to do that by eliminations and so on. And we're going to have a wonderful time on Sunday. No problem. As a matter of fact, you know the new book that we're going to be moving to. Monday, we're going to be moving to the books. Because we only have 2 problems left for Monday, and then it will be the next book. So when you get that book started, we're going to make a light work of it. Because that book is a continuation from primary school. With your ratios, your percentages, your simple and compound interest, your foreign exchange, your decimal places, significant figure, and standard form. So you're gonna have a wonderful time right there. Right, so you're not the only one who is extremely tired. I'm extremely tired. If you want me to do a problem, you have to say it early on Sunday. So if you want me to do a problem involving functions, just let me do it early on Sunday. When you're making requests for me to solve problems, close to the end of the class, that's not a good time to ask. Just ask early in the class and I will have enough time to do it. Okay. So, thank you all for joining, for commenting, for sharing, for following, and everything that will cause this program to move forward. Because if I'm just here all by myself, then that's not much progress. So thank you all for playing your part. So, have a good night, have a restful and peaceful night, and I say what? Goodbye until Sunday.